All right, lesson 1.3, properties of exponents. At the end of the lesson, you should be able to simplify expressions with exponents. There's a lot of rules to exponents we're going to learn. We're going to be simplifying them. So let's jump right into it. So first off, we're going to kind of compare exponential form, the base, and expanded form. But in general, like, let's say that I have something like 4 to the second power. All right. Well, the 4, this number right here, the big number, that's what we call the base. All right. And then the 2 up here, well, that's what we refer to as the exponent. So we have a base, we have an exponent, and then the whole thing together, this entire chunk, that whole thing is called a power. All right. So those are kind of the different pieces. So when I'm referring to the base or the exponent, we kind of know what we're talking about. So let's jump right off here. In exponential form, I want to compare 3 different scenarios and just show you the difference, because this is where a lot of kids get into trouble. So let's say you have something like negative 2x to the third. Well, technically the base right here, the only thing that's being raised to the third power is x. X is the thing that you're multiplying by itself 3 times. Just like over here, 4 squared really just means do 4 times itself, and then you're doing it 2 times, the exponents twice. Over here, we're doing x 3 times. So if I were to write this out in expanded form, it's really just negative 2 times x times x times x. That's how I'd write it out expanded ways and not using exponents for short. Now, contrast that with this. Looks very similar. However, now the base is different. Now the thing being multiplied by itself 3 times is not just x, but it's in parentheses, it's 2x. So now we have this negative sign, and then we have basically a 2x times another 2x times another 2x. And I could have put dots in there, or I could put parentheses. It really doesn't matter, however you want to kind of do it. And then if we compare that even with the negative 2x to the third, well, now the base, or the thing getting multiplied several times by itself, is the whole part, negative 2x. So now you have this negative 2x times negative 2x times negative 2x. So you need to really understand, because what happens is a lot of time kids kind of treat all 3 of these the same, especially when they're evaluating with a calculator, and they end up getting the sign wrong. And it's usually because of that fundamental understanding of who the base is. All right, so let's just kind of write these in expanded form. This is just kind of more to help you out. Conceptually, I haven't really seen this on tests that say, hey, write it in expanded form, but just kind of trying to help you out. So on this one, we'd have 4y as the base, and it's times itself 3 times. So that's the long version, instead of using exponents for short. Now in this next one, just the a is being multiplied by itself twice. That's what you'd do first. And then you'd simply slap the negative sign. I've even seen people kind of put negative 1 in the front, or you could just put a negative in front of all that. Doesn't really matter. Number 3, the third power, the only thing being raised to the third power is the x minus 3. So this is the base, and it's being multiplied by itself 3 times, which we will actually do this later in the course when we expand polynomials. And then the 2y squared just gets multiplied at the very beginning. That was not part of that third power. And actually, I guess if I wanted to expand this out a little bit further, I could even, the 2y squared could be expanded, and it would be 2 times y times y. So that would be like fully expanded out. All right. We don't really use expanded form a whole lot, just because it's easier to use exponents. So the first couple of rules I want to give you deal with 0 exponents and negative exponents. 0 exponents are usually pretty easy. Basically says that anything raised to the 0 power is equal to 1. All right. So, if I say, hey, what's 5 to the 0 power? Well, the answer is 1. What if I say, well, what's 10 to the 0 power? The answer is 1. What if I say, what's x, y, z to the 4th, all raised to the 0 power? It's 1. Anything, I don't care what the base is, if you're raised to the 0 power, you're 1. So that one's kind of nice when you get that type of question. You just know what the answer is. Now, negative exponents are a little bit trickier. So negative exponents, it basically says if you have a non-zero base raised to a negative exponent, it's equal to the reciprocal of the base. So that's kind of important. The reciprocal of the base raised to the opposite positive exponent. So in the example over here, they give you an example of 7 to the negative second. So 7 to the negative second power. So the first thing you want to do is, since the base is 7, I want to do the reciprocal of the base. And then I want to raise that to a positive exponent. Instead of the negative 2, I'm going to raise that to a positive 2. So you could write the answer as 1/7 squared. If you were to actually multiply that out, if you were to expand that, 1/7 times itself is going to be 1/49. So all of those would kind of be valid for that. And then they show you, well, what if the base starts out as a fraction? What if the base is 3/2? And I'm going to do that example over here on number 5, so I won't kind of go through that one. So let's look at this. Simplify each of the following. 2 to the negative third. Well, that's really, my base is 2, so I want to do the reciprocal of that, and I want to raise it to the positive third power. All right? Which you could also write that as 1/2 to the third, or at the end of the day, it's going to be 1/8. Because if you were to expand that 1/2 times itself 3 times, the 1 never really changes. So that's kind of why I could just put a 1 there. But then 2 times 2 times 2, be careful. Some people accidentally put 6, but it would be 1/8. Now number 5 is kind of tricky because there's several pieces here. So first of all, this is our base. So first thing we want to do is we want to do the reciprocal. All right. Second thing we want to do is we need to change our power to positive. And then the third thing we got to do is we got to not lose that negative sign in the beginning. But the negative has nothing to do with the 4th power. It's just the sign out in front. So if I want to kind of break this down and clean this up a little bit, if I do 4/3 times itself, if I expand it out, and then put a negative in the very front of all that, I could get an answer. 4 times 4 times 4 times 4 times 4, 4 times is 128. And then 3 times 3 is 9, 27. I believe another 3 makes 81. And then we got to put the negative sign in front. So negative 128/81. And then we could get into, is there something that can go into both of those numbers? We could reduce it down if possible. But right now we're just going to leave it here, and I'm not even sure if that can reduce down, because the only things that go into 81 are 3 and 9. And I don't think 3 or 9 goes into 128, so I think we're probably pretty good right here. Now, sometimes that gets annoying, writing things out in expanded form long ways. So there's kind of rules that we can develop, or properties, that might speed this up. And I'm not going to go through every single rule on the chart. I'll kind of let you read through it. But there's a few main differences that we want to focus on. So the product of powers, basically I'll kind of underline the key words that we need to get out of this. That whenever you want to multiply powers with the same base, you're going to add the exponents. So they say, 4 to the third times 4 to the second. A shortcut is just to add the 3 plus 2 and get 4 to the fifth. Because if I wrote it out, 4 to the third times 4 squared, basically I end up with 5 of those. But a lot of kids want to make the mistake and they want to multiply, but you're going to add those exponents when you multiply a power times a power. Now, when you divide powers, you actually are going to, divide powers, you're going to subtract the exponents. When you want to multiply powers, You actually add the exponents. And you could think about this one, the 3 to the 7th over 3 squared. You could think about it as 3 to the 7th. That's 7 of them. And then all over 3 squared. And then if you started canceling your 3's, you'd end up with 5 3's on top, which is kind of where they get that 3 to the 5th. So it's just a subtraction move. Now, when you want to raise a power to a power, so their example is 4 to the 3rd raised to the 2nd. You actually can multiply the exponents. So that's kind of what we did up above. When we had that little example up above that said 4/3 raised to the 4th power, I could have used this property. I could have said, well, hey, I could just raise the base up to the 4th power, raise each part separately up to the top, which kind of gets into right down here. I'm allowed to kind of multiply those out and write shorthand where I could have just had 4 to the 4th over 3 to the 4th. You raise both pieces to that power. And power of a product, we don't really use this a ton, but I'll just kind of leave it up there in case you need to do it. But it just says you can multiply both pieces separately. So like if you have 3 times 4 squared, which would be 12 squared, you can do both pieces separately. So you can do 3 squared and then times that by the 4 squared and do the pieces separate. And then they show it with letters as well. Let's just do some examples. I think it's a little bit easier. So number 6, we have 2x to the 3rd times a negative 5x. And if you want to, you could even think about this as parentheses. No big deal. I do these separately as far as I do the coefficients first. So when I look through here, my coefficients are 2 and negative 5. So I'm going to multiply 2 by negative 5, and I'm going to get negative 10. Well, now I'm going to do the exponent pieces. I have an x to the 3rd times an x to the 1st, because there's really a 1 there. And whenever you multiply your powers, we want to add the exponents. So this is going to be negative 10x to the 4th. And if you need to, like if you're struggling, you could expand it out and say, well, negative 2 times x to the 3rd times a negative 5 times 1x. And when you gather it all up, you're going to have negative 2 times negative 5, and then you're going to have 4x's total. So you could always expand it, multiply it out, and then put it back together, but these rules just kind of shortcut it a little bit. All right, number 7 here kind of combines some rules. So the first thing is I see a base. This whole fraction right here, all that is a base, and it's raised to the 2nd power. So I can raise both the top and the bottom to the 2nd power. So I can say, hey, this is really just a, and a lot of times I like to put a 1 there if there's not one there. Just in my mind, it's easier. So I can raise the top to the 2nd, and I can raise the bottom to the 2nd. And now I can use this rule right over here, the power of a power, because we're raising a power up to another power. So we want to multiply here. All right? So that's going to come out to the a to the 1 times 2, and then b to the 4 times 2, all over. And on the bottom, I have b to the 7 times 2, or b to the 14th. All right? Well, now I got some leftover going on here. If you think about it, I could subtract. I'm not really a subtraction fan here because 8 take away 14 is going to give me a negative. So this is kind of where people go into 2 different routes. Some people, so let's just kind of go 2 directions here. Some people who are hardcore rule followers will say, well, I have a squared. There's no other a on the bottom to worry about. But I got to divide b to the 8th by b to the 14th. So they would apply the rule and say, well, I'm going to subtract the exponents. Well, if you do that, you're going to get a squared b to the negative 6th. And now you're going to have to fix that by doing 1 over b to the 6th. Because we got to do the reciprocal to the positive power. And then when you multiply that out, you get a squared over b to the 6th. Now, to me, that's a lot of work. I think of things as like canceling. So if I picture there's 8 of these b's on top, and there's 14 b's on bottom, if I were to write all those out and cancel them, these 8 are going to cancel with 8 on the bottom, and it's going to leave me 6 down there. And I get to the answer much quicker. So that's just kind of how I like to do those problems. I like to picture me expanding it out in my mind and then just canceling. I think it's way easier, and I talked to Mr. Davis, and he kind of does it the same way. All right, and I'll be honest, you just got to do a lot of examples with these to get kind of good at it. So number 8, let's just start cranking through. So I have a 5 on top. There's really a coefficient of 1 on the bottom, so there's nothing to do there. The 5's going to be here. But now, if I think about the canceling method, I have 1u on top and 2 on bottom. So if I cancel those out, I'm going to have 1u left over on the bottom. The top one will disappear. And then if I have 6 v's on top and 2 v's on bottom, the 2 on the bottom are going to disappear, but I'm going to have 4 left up top. And that's just going to be my answer. Now, if you're a hardcore rule follower, you'd say, well, I have 5 divided by 1, which is 5. And then I got to do u to the 1 take away 2 power. And then I got to do v to the 6 take away 2 power. And it's not too bad, except for you do end up with this u to the negative 1. V to the 4th is fine. But then that u to the negative 1, you got to fix, and you got to say, well, it's really the reciprocal of u to the positive 1. And then you got to kind of multiply that out, and you'll see that the u to the 1 stays to the bottom because these really like have 1s under them because they're whole numbers. And when you multiply all the way across the top. So I'm not going to keep showing you that way of subtracting the exponents because I just don't really do it that way. I like to kind of just do it by canceling. I think it's easier. So kind of showing an extreme shortcut. When you get into fractions with negatives, just know that because of that reciprocal rule, they're going to fly to the other side and they're going to be positive. So for instance, up top, that u to the negative, or x to the negative 1 is a problem. It's going to end up reciprocating and going on the bottom, and it's going to be x to the 1st. So it's gone now. It's not on top anymore. The y then in the negative 2 is also going to jump down here to the bottom. So it's gone. It's not on the top anymore. The x to the 3rd is fine. It's a positive exponent, so I'm going to leave it alone. And then that y to the negative 5th is a problem, so I'm going to throw it up top. And now it's pretty simple to cancel things out. When I look at what's going on here, I have 5 y's on top, 2 y's on bottom. These two are going to cancel out with 2 of those, and I'm going to just end up with y to the 3rd on top. These 2 are on the bottom, so I just apply my rule, x to the 1st times x to the 3rd. I now have 4 of those down there. And this is what it's going to simplify to be. Now, you could have did that differently. You could have said, well, x to the negative 1, subtract 3, and y to the negative 2, subtract. I have to subtract a negative. This is why I don't do this way, because subtracting negatives, you can kind of make mistakes. But negative 2, take away a negative 5. And when I clean that up, this ends up being x to the negative 4, y to the positive 3. And then I got to fix that by doing the inverse, or doing the reciprocal, I should say. And if I want to just put a 1 under it so I can multiply, you kind of end up to the same spot. So you're going to have to develop your own style. My style, though, with fractions is just throw negatives to the other side, make them positive, and then cancel. Life seems to work out easier for me that way. All right, last little bit. Properties of exponents, scientific notation. So scientific notation, remember, is you have a number that's bigger, that's between 1 and 10, and you're trying to express it. So for instance, let's say that I have a giant number like 23 million. All right? And that's not that big a number, but let's say I want to express that in scientific notation. So what I'm going to do is, right now the decimal point is kind of here for 23 million. I need to move the decimal point and get until I get to a number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7. 7 spots there. I get to a number 2.3. And I moved it 7 places, so I have to do 10 to the 7th power. Since I moved my decimal left, I got to increase my exponent up there. So this is one way to write 23 million. All right? And the rule is that this number in front always has to be a number between 1 and 10. All right? So kind of make sure that you keep that. So here's how we can do scientific notation. If you want to multiply two huge numbers, you can do it in scientific notation and it might be easier. So what you're going to do is you're going to do just this first part, just the number. So you're going to do 3.5 times 15. And when I do that, I get 18.2. And then when I do my exponents, 10 to the 8th times 10 to the 5th, I add the exponents because I'm multiplying powers. So that would be 10 to the 13th power. Now, my answer is not expressed in scientific notation because I have a little bit of a problem right here because it's not a number that's 1 through 10. So to make it 1 through 10, I need to move the decimal one more place. But since I just changed that decimal, since I moved it 1 to the left, I need to increase my exponent by 1, so now that they represent the same number. Both of these here represent the same number, except for this one is now in scientific notation. Scientific notation. And I could see that because, on this number up here, if I moved it 13 places, it's going to end up being the same number as if I move this one 14 places. It'll be the same number with the same amount of zeros. So moral of the story is, multiply the front numbers, do your exponents, add them together, and then you may have to adjust if you don't have a number between 1 and 10. Now, when you divide scientific notation numbers, so when I want to divide these two, very similar. I'm going to do the first part just straight up. I'm going to just punch in my calculator, 9.1 divided by 1.3, and I think we end up with 7, which is nice because I'm not going to have to adjust this one. And then now, I have 10 to the negative 3rd divided by 10 to the negative 8th. So, negative 3 subtract 8, because I want to subtract my powers. So if I add a negative, that's going to give me 10 to the negative 11th power, which is going to be a very tiny number, a very small number. So you also could have thought of throwing that 3rd to the bottom. You could have thought about throwing that down here. But then you'd have 7 times 1 over 10 to the 11th, and you'd have to fix it, and so it just becomes a little bit easier. At least I find on the scientific notation ones, it's a little bit easier to just subtract the two exponents when you're dividing. All right, so definitely didn't have enough notes here to give you every single possible thing that comes up, but hopefully it allows you to go into the practice and get your hands dirty. And then I picked some SAT questions for the back, but we'll definitely get more practice on this as the year progresses. See you.